So, hello once again, good evening. And today I'm going to talk about normalization. So, this is for the information management course. So, what is normalization? So, normalization is a method or a technique that we use in database management so that we could avoid anomalies. You could avoid duplication of data, insertion anomalies, deletion anomalies. So it basically is used for organizing data elements into tables so that it won't be redundant and it won't cause an anomaly to the overall database. So there are actually different types of normal forms, but in this one, so I only included first normal form, second normal form, third normal form, and the voice code normal form. So for this one, I'm just going to discuss the first three normal forms. So actually, there's actually a fourth normal form and a fifth normal form, but it's very unlikely that you would use that. A lot of companies just use that for example, like really big systems, very complicated systems. But I'm just going to discuss the three normal forms. So there are rules in normal forms. So the first one would be the 1NF rules, or the first normal form rules. So rule number one is that single valued attributes, atomic values, should be followed in your table. So what does that mean? So in this example, we have employee skills and employee mobile. So employee name and employee ID. So in this one, so as you can see in the employee skills of John Tech, so you have Python and then JavaScript. So that should not be the case because that would cause anomaly. So what you could do with that is that you could um, instead separate them. For example, in this one, so um, for the employee ID, you have two employee IDs, which is one, but with the same employee name and employee mobile, since it's the same here. The only thing that's different here is the employee skills. So what we could do is that we could separate these two values. So we could separate Python and JavaScript, and instead have two Jantic records with Python one value and then another value for JavaScript by the same employee name or employee ID. And so the second one will be values stored in a column should be of the same domain. So of course, when defining a field or a column, so for example, employee ID is usually the data type is usually um, integers, or the employee name is usually string, or for example, employee number is usually number or integer. So uh, what the second rule means is that you can't have different types of data types in one field. So for example, in employee mobile, you can't have like a string data type in that sense. It only allows numbers. So in this example, there actually isn't you know um, sagol na data type. So that's fine. It's fine. And so for the next one is all the columns in a table should have unique names. So basically, so you won't be too confused. So it should have different names. So you can't have two employee names fields, because that would be very confusing. It would cause an anomaly. And so for the last one, we have the order in which data is stored should not matter. So it should not matter. Self-explanatory. So this is the final table. So what we really changed, what really just changed here is the employee skills. We separated them to different records. And so we proceed to the 2NF. So there are two rules in 2NF lang. So the first rule would be it should be in the first normal form. So we're done discussing that. And so the second one would be it should not have partial dependencies. So what is partial dependencies? So basically, in a table or in a database table, we have the primary keys and the non-primary keys. So by this, in this example, we have two primary keys. These are called composite keys. And so we have two non-prime keys. We have marks and teacher name. So partial dependency just means that um, a non-prime key, so either of these fields, should um, should have a connection with um, only one of the primary keys. So in this case, for example, so in marks, you could say that is marks connected to student ID? Of course, it's connected to student ID. And is marks connected to subject ID? So of course, it's connected to subject ID. So what you should do is that you should compare these non-prime keys to the primary keys it is if it has a relationship. So in this next non-prime field, we have teacher name. So is teacher name uh, dependent on subject ID? Of course, it's dependent on subject ID since subject refers to one teacher. But is teacher name related or relate has a relationship with student ID? So that that is not kuan that is usually not the case since student ID is not usually directly related to teacher name. So what you could do instead is that you could separate or make another table to these. So for example, in this one, so we have now the two tables. So we have now the subject ID and the score table. So by by separating the teacher name, so you also separate another table. So in this case, since teacher name is only connected to subject ID, so you should emphasize here that subject ID is connected to teacher name. So in this one, we have the subject ID, subject name, and the teacher name. So it's there. And then we have another table which is student IDs, subject ID, and marks. So to summarize, you basically just have to watch out if these non-prime keys or fields are related or has a relationship with any of the composite keys or the primary keys. And if it doesn't have, um, or if that non-prime key is only related to one primary key, so you should separate it. So for the 3 and F, so we move on to the 3 and F. So there are only two rules again. So it satisfies the first normal form and the second normal form. And so the second rule would be it doesn't have transitive dependency. So what are transitive dependencies? So basically, in a table, it's very different from the one that I discussed earlier in the 2 and F. So basically, a transitive dependency is that if um, one non-prime key, so not one that is not a primary key, is connected to another non-prime key, so you should separate them into another table. So in this case, total marks is completely related to exam type, but exam type is not a primary key. So what you could do is that you could separate these two. So you could separate these two and turn this into two tables. So this is what will happen. So you will make a new exam type table and put uh, exam type and total marks on there. So exam type and total marks. And you should of course make another exam type ID since you're making another table. So that is just basically what you should do. That's it. You should make another table if one non-prime key is has a relationship to another one non-prime key. Okay. So on to the next slide. So next up, we have application to my field. So obviously, normalization is very important it is widely used in the IT industry, especially
for the people who are working on, the database management system, na part of the IT industry. And so, for example, in our informant subject, we are tasked to make an information system in Microsoft Access. And so if you have anomalies in Microsoft Access, it will be very hard for um, for it to for you to make queries or stuff like that or reports if you have anomalies. So of course, if you're dealing with data is very important because it is very crucial, especially in today's world in social media and, for example, in bank accounts. It's very crucial dyan ang data that it won't have any anomalies, won't have duplicate records because just one wrong or one anomaly, it could affect the whole system. Because for example, in bank account records or bank account like databases, so it's very important that you don't um, make the the data redundant because it would affect the whole system. So it would not only make your customers think that your company is bad at or terrible at handling data, but it would also affect your resources because you're uh, adding another record to your database, and the database is usually, it's growing, and it's something that takes up space or that takes up storage. And so that also means that you the and having more storage means more cost for the company to pay or handle. So there's stuff like that. And so that's it. Thank you very much. Thank you so much for listening. Thank you, Miss, for the opportunity, and um, thank you.